when you find the percent by mass, you have to find the total weight. So you got to find the molar mass. And once you find the molar mass, then you're going to have to divide the element's total mass, whatever it totals up to be, its individual weight. You're going to have to divide that by the overall weight of the whole compound, or the molar mass. Simple. Okay? So you do the step like we did today, then divide by the total. That finds their percent. Any questions you have on that? Yes?
Wait, so you divide by, wait, what total? What?
Okay, so you'll see when we go through it, okay? So, first thing you do, find the molar mass. You know how to find the molar mass, right? Okay? So, Adam, if we were doing, for example, the first problem that you did, molar mass, and I had you find the mass of carbon in glucose, which is C6H12O6, okay? Does everybody have that in front of them? C6H12O6. So if I say, what's the percent of carbon in that compound? You go, carbon's total weight is what? 72 point, okay? Should be 72.06, right?
Yeah.
Okay? Then you would take that and divide it by 180.18, right? Times 100. And that would find your percent of carbon. Okay? So, go ahead.
72 goes on the top.
Yep, 72, each individual weight goes on top. You'd always divide by the total. So we'll do a problem for you. Real simple. So here's CO2, and you go, okay, he said I had to find the total weight of the compound. So I'm going to go ahead and I'll say I got 1 carbon, 2 oxygens. Carbon's weight is 12.01. So that's 12.01 total for carbon. And oxygen is 16. Got that memorized. So that would be 32. So it's 44.01 grams per mole is the total. Any questions? Got the total? Yes.
See that of that.
Okay, but that's number 1 step. Second step, it says find the percent mass of carbon. So I just want carbon, so I'm going to go 12.01 grams divided by the total. And times it by 100. And I've got my answer. That's the percent. That's all you do for percents. Not that difficult. Percentage is just how many, it's just a ratio, it's kind of a ratio in a way. It's based upon this, but we do it as a percent. So this ratio would be like 0.27 to 1 of the whole thing, but we do it as a percent, so it would be 27.29%. Any questions? That's all you do. We don't really use percentages much in here and do many of these type of problems. Okay, we don't really use it for any purpose. Okay, now we do take percentages starting tomorrow. We do take percentages and use those as a big part of finding a formula. So that's why we're kind of doing some things with percentage, so you recognize how they were found. Okay, the type of problems you guys really struggled with on the test was changing grams to moles, moles to grams, grams to molecules. Okay, and so I'll go through a couple of those with you here. But any questions on finding the percent mass? Okay, you'll have a couple of those type of problems that you're going to have to deal with on the assignment. Okay, you guys can write that down, and then we'll talk about the steps you need to do to solve that problem. Okay, again, we're doing a problem, we've got to find the molar mass. Okay, the reason why we've got to find the molar mass, it tells us how many grams per mole we have. And so, we're dealing with moles, and we need to know a ratio of what the weight of the compound is to what 1 mole of the substance would be. So again, we just real quick, you guys will get really fast at these, maybe too fast sometimes because you'll make some errors because you'll go through it too quick. But all you do is you go, I got 1 of each element there. I've got 1 Na. I got 1 O. I got 1 H. So I don't really have to multiply. I can just write them down and add them all up. So this is 22.98. Oxygen 16. And hydrogen is 1.01. And I don't have to multiply because they're just the same. So then I add everything up and I get 39.99 grams per mole. So down there it's 39.99 grams per mole. Questions? What's that?
And in here it says 29.9 or 22.99 per.
Okay, if it said 22.99, then it would be 40.00. Okay? Right? So, this is your ratio. This is what you use to solve the problem. Okay? So, we have 0.43 moles of NaOH. Some of you get yourself into a bad situation because you want to start writing numbers in right away. If you don't want to write numbers in right away and just write the units in, that's probably better. You're going to get them right. Units won't lie. So if I got moles of NaOH up here, I'm going to put moles of NaOH down here. They cancel out. Okay, I want to find grams of NaOH. They go up here. So I haven't put any numbers in yet. Then what I would do is I just go here, and that's my ratio. For every 1 mole, I have 39.99 grams of NaOH. Or 40, if you want to put it. It's probably not going to affect the answer anymore. So moles cancel, I end up with grams. So 0.43 times 39.99 or 40, and I get an answer at 17 grams.
What decimal place be around to?
Right there. Okay, any questions, any thoughts you guys have? This is not new. This up here is not new. This is what you struggle with on the test. This isn't new. The only thing that's new is we're figuring out a molar mass based upon a molecule instead of an atom. Okay? I know we're running out of time here a little bit, so I'm going to do skip over one I showed the other class because it's just the opposite of this. You just put grams above, put grams below, and you multiply by moles, so it's moles over grams. I'm going to do one that's a little bit more difficult than that. You can write that down. So now we're looking at not moles, but now we're actually looking at how many molecules. So carbon dioxide is a molecule, and we want to know the exact amount, not moles of molecules, but actual molecules. So down below you have the conversions. We did this one in class. CO2, we took 1 carbon, 2 oxygens, and we found out that it totaled up to 44.01 grams per 1 mole. And everybody knows that 1 mole is equal to that number of particles. In this case, molecules. So this one is just going to be a 2-step. So all I'm going to do is 2 steps. So I'm going to put my sample of my 10 grams out in front of CO2. Then again, don't put numbers in. You can put units, grams of CO2. And what I'm going to do that should be grams of CO2 down there. Since I'm running out of room, I'm writing too small. And up here should be moles of CO2. So for every 1 mole, I have 44.01 grams. So my answer right now would be moles of CO2. So my next step should be what?
Which molecules?
Moles cancel out. Want to cancel them out?
Well,
I'm not going to put numbers in. So right now I have moles.
how come you didn't cancel out grams?
Okay? So the next thing I'm going to do is put up here how many molecules are in a mole. So it'd be 6.022 times 10 to the 23 molecules. To 1 mole. Okay? And then I just multiply it out.
Is that 44 point?
44.01. 44.01. Some of you still are not doing scientific notation correctly when you have to do these calculations. I don't know what to do with you other than have you come in and check to see how you're doing it on your calculator and make those corrections. You need to get where you're more successful at that. The answer would be 1.37 times 10 to the 23rd. Be your answer. So, haven't left you a lot of time, but you have 8 problems to do for tomorrow, and I'll give that to you here up on the board. So again, this is nothing new. This is review. Okay, this should not look like brand new material. The only thing new is using the molar mass. So, problem 32. A and C, and that's on page 253. Those are percent problems. And then page 886 should be problem 100. I better check that. I think it's 101, I'm sorry. 101 through 103, I'm not sure why. Yeah, 101 through 103. A and B. Okay, and those deal with moles. Do those for tomorrow. I don't think I had anybody that didn't do the assignment. So great job on that. We'll kind of make you get back into school right away by doing homework and that, but that's okay. It's good to get started doing that. Then we'll tail off here at times. We'll do labs and some things like that. So yes.
Do you want those in my notes?
You can put them in your notes. I won't collect them. So, okay, we'll see ya.